section 1.2, we're going to talk about the measures of angles, okay? Anytime you're talking about an angle, remember that an angle is really two rays that come together. And we might draw it as segments, but they're going to come together at a vertex, okay? Anytime we're talking about an angle, we're talking about a part of a circular motion, okay? We measure angles usually in degrees, and we talk about how much of a circle I've opened up, okay? We're thinking of kind of a circular motion. Think of kind of a pivot, and something's opening up around that pivot, okay? So a couple of things here. Hopefully you all know that an angle that basically creates kind of a rectangular edge there would measure 90 degrees, okay? That's usually referred to as a right angle. An angle that's less than 90 degrees might look something kind of like this. Maybe that would be about a 60-degree angle. Any angle that's less than 90 degrees but greater than 0 degrees would be considered to be an acute angle. And an angle that's larger than 90 degrees, and for the purposes of our book, we're only talking about angles up to a straight angle. Angles larger than 90 degrees, less than a straight angle, maybe this is about 120 degrees, we could call that an obtuse angle, okay? Now, a straight line and a straight angle are kind of the same thing. You can open an angle to the point that it's straight, all right? And that would look something kind of like this. And so we say that a straight angle has a half circle motion. A half of a circle is 180 degrees, okay? If you open up through a full circle, of course a full circle has 360 degrees total going all the way around there, okay? If you open up all the way. But the angles we're going to deal with are going to be between 0 and 180 degrees until we get to the circles unit. Okay, so if they ask you to count angles or something like that, you're looking at angles that are a straight angle or less, basically, is what you're looking at, okay? By the way, from a naming standpoint, we could name this a couple of different ways. If this was point A, B, and C, we could say that this is straight angle ABC, or we could say it's straight angle CBA. We can also say this is line AC, or line CA, or line BC, okay? So we will see some cases where something could be named as a line or as an angle, which is something I don't think we saw in the previous video, all right? So that's some basic stuff about angles. Some of you may know, some of you may not know, angles can actually be broken up into parts that are smaller than degrees, okay? It turns out that 1 degree can be broken up into parts called minutes, okay? How many minutes do you think there might be in a degree? Well, if you're thinking about a clock, I don't know if you can see the clock in the video, but if you're thinking about a clock, there are 60 minutes in an hour, okay? It's the same setup. It comes from the same background. Blame the Babylonians if you don't like it. 1 degree is the same thing as 60 minutes, okay? And the symbol they're going to use for minutes is actually a little, kind of looks like a little apostrophe, okay? Minutes break down into smaller parts too, okay? Just like feet break down into inches. Minutes, 1 minute is going to be equal to 60 seconds, okay? And of course, the second symbol is going to look like 2 apostrophes, okay? So for example, I might have something like 20 degrees, 10 minutes, and 32 seconds. And this will allow us to combine, add, subtract angles without actually using fractions, okay? So it's not used a ton. It's not the most common thing. You're probably not going to see it on your ACT, but I think it's something to be aware of, okay? And you will see it a few times in a couple of problems in this book, all right? Now, there are a couple of issues that I need to address having to do with this. First of all, let's talk about conversions, okay? So if I had something and I wanted to go from a fraction number of degrees to degrees and minutes, or degrees, minutes, and seconds, something like that, how would that work? Well, let's say I had 25 and a half degrees, okay? If I'm trying to go to degrees and minutes, the whole number value is going to stay degrees, okay? So it's going to be 25 degrees, and then I've got a half of a degree, okay? Remember, each degree has 60 minutes in it. So you're really trying to figure out how many minutes would be in half of a degree. So I'm not using a fraction, okay? So I can take 1/2 of 60 minutes, right, which would be the same thing. And of course, off the top of your head, you probably know half of 60 is equal to 30 minutes. So we could say 25.5 degrees is the same thing as 25 degrees and 30 minutes, okay? That's what that would look like. Now, this can be pretty easy. You know, if I had something like 37 and 3/4 degrees, you might know, okay, it's gonna be 37 degrees. I need to take 3/4 of 60 minutes. And you might be able to kind of think through that. You could say, okay, 1/4 of 60 is 15, and I want 3 of those fourths, 3 15s would be 45. You might be able to figure that out, okay? That'd be 37 degrees and 45 minutes, okay? Part of the reason that I have us do this is this helps us to do a little bit of reviewing with ratios of numbers, okay? And I want to make sure that you know how to take a fractional part of a number, okay? When you take a fractional part of a number, you're really taking that fraction times the number, okay? When I was in middle school, I learned that the word of usually referred to multiplication. So 3/4 of 60, that's the same thing as taking 3/4 times 60, okay? And again, you could do a decimal, you could take 0.75 times 60 and you get 45. But this is a really easy calculation. I partly do this to review a little bit of working with fractions, okay? Remember, when you multiply fractions, you don't have to worry about common denominators. It works out exactly the way you wish fractions worked out all the time, okay? You can write both numbers as fractions, and you can just multiply across the top, and you can multiply across the bottom, okay? So 3 times 60 is 180. On the bottom, 4 times 1 is 4. 180 divided by 4 is 45, and you have your answer there, okay? Now, one of the interesting things for those of you who like to do things a little bit more quickly, notice you can actually divide first, because what we're really doing here is we're multiplying by 3 and we're dividing by 4. So you could actually divide 60 by 4. What's 1/4 of 60? A lot of you might know it's 15. We're going to take 3 15s. 3 times 15 is 45. So we're multiplying by this, we're dividing by that. That's really what happens when you multiply by a fraction, okay? So the reason I mention that, a lot of you may know what 3/4 of 60 is, you might know what half of 60 is. You might have something that's more complicated. You might have something like 18 and 3/5 degrees or something like that. The same setup. You're just taking 3/5 of 60. You're taking 3/5, you're multiplying it by 60. And again, you can really just write that over 1. 3 times 60 is 180. 5 times 1 is 5. Okay. If you divide that out, I believe you're going to end up with 36. Okay, 36 minutes. So it'll be 18 degrees, 36 minutes. Again, if you want to say what's 1/5 of 60, 1/5 of 60 is 12. Divide first, and then multiply by 3. 3 times 12 is going to be 36, and you get the same number. So there are a bunch of ways to do this, but I wanted to make sure you'd seen that. All right, one more thing. So let's say that you want to go the other way, okay? Let's say you have something like 32 degrees and let's say 20 minutes, okay? And you want to convert that into a fraction, okay? Remember that a fraction is always a part over a whole, okay? So first of all, our 32 degrees is going to be 32 degrees. Nothing changes there, okay? That's going to be my whole number part, okay? We now have 20 degrees out of a total possible of 60 degrees, okay? Part over whole. You've got 20 degrees out of a total of 60. You should simplify that fraction, okay? That's the fraction 1/3, and we can write that as 32 and 1/3 degrees, and that's basically how you can write a fraction using degrees, okay? Let's say I had something like 126 degrees, and let's say we do something like 14 minutes, okay? Same kind of thing. Whole number part's 126. We have 14 minutes out of a total of 60 minutes. We have this part out of a total of 60. So you just do part over whole, and again, always simplify your fractions, okay? So this is going to be 126. 2 divides out of both of those. That's going to be 7/30, okay? So 126 and 7/30 degrees. So you can go back and forth with these. In the next video, I'm going to show you how some calculations can be really easy if you're working with just degrees and minutes or degrees, minutes, and seconds. But there are a couple of things that maybe might be a little bit unexpected, and we'll look at that in the next video.